Hi everyone, in this video we will take the indeterminate form infinity minus infinity. So if you have infinity minus infinity, you have to convert it to 0 over 0 or infinity over infinity to use Hopital rule. For the first question we have limit 1 over x minus 1 over sine x. So firstly, if you do a direct substitution, you will get 1 over 0, which is infinity, minus 1 over sine 0, which is 1 over 0. Also we have infinity, so we have infinity minus infinity. Now you have to modify the function inside limit, so you have to rationalize the denominator. 1 times sine x equals to sine x minus 1 over x, which is x, divided by x multiplied by sine of x when x goes to 0 from right. Then we have limit, but before we continue you have to substitute x equals 0 in this function. We have sine 0, 0 minus 0, 0 divided by 0 times sine 0, which is 0. So we can apply the Hopital rule. The derivative up is cosine x minus 1, and the derivative down you have to use the product rule. So name x as u, assign x as v, then you have to use the product rule. This is the product rule. So you have to find u prime, which is 1, multiplied by v, which is sine x, then plus u which is x, multiplied by v prime, which is cosine x. When x goes to 0 from right. Then you have to substitute x equals 0, and the inside function we have cosine 0, 1 minus 1, 0 divided by 0 plus 0 times cosine 0. Also we have 0, so you have to use Hopital rule again. So you will have limit the derivative up divided by derivative down. Up we have negative sine x, and down we have sine x, the derivative is cosine x, and here also you have to use the product rule again. This is u and this is v. So we have u prime, which is 1 multiplied by v, cosine x, then plus u, which is x multiplied by the derivative of cosine, which is minus sine. So we have minus x sine x when x goes to 0 from right. Now you have to replace x equal to 0, and you will have minus sine of 0, which is 0 divided by cosine 0, 1, plus cosine 0, 1. So we have 1 plus 1, which is 2, minus 0 times sine 0 equal to 0. So we have 0 over 2, which is 0. In part B, we have limit ln of x minus ln of 1 plus x when x goes to positive infinity. So by a direct substitution, ln of infinity equals to infinity minus ln 1 plus infinity, which is ln of infinity, give us infinity. So infinity minus infinity, you have to convert it to 0 over 0 or infinity over infinity to use the Hopital rule. So how to make this? To make this, you have to use the one of the most important property of the function ln of x. And as you know that ln of u over v equals ln u minus ln v. So you have to use this rule in reverse way, because we have ln minus ln, so you can write it in single logarithm and you have to divide them. So this is equals to limit ln of x divided by 1 plus x when x goes to infinity. and since len is a continuous function, so you can enter limit inside and you will get len of limit of x divided by 1 plus x when x goes to positive infinity. Now if we replace infinity here, you will get infinity over 1 plus infinity, so we have infinity over infinity. So we can use Hopital rule and you will get len of limit of f prime, which is 1, over g prime, which is also 1 when x goes to infinity, and 1 over 1 is a constant, equals to 1, so the inside limit is equals to 1. So we have len of 1, which is equals to 0. In part C, you have to find limit 1 over x minus 1 over e to the x minus 1, and by a direct substitution for 0, you will get 1 over 0, which is infinity, minus 1 over e to the power infinity, and e to the power infinity equals to infinity, minus 1, which is, sorry, e to the power 0. Okay, in part C, we have the limit 1 over x minus 1 over e to the x minus 1 when x goes to 0 from right. By a direct substitution for 0, you will get 1 over 0, which is infinity, minus 1 over e to the power 0 equals to 1, 1 minus 1, 0, 1 over 0 equals to infinity, and we have this indeterminate form, so you have to convert it to 0 over 0 or infinity over infinity to use the Hopital rule. So you have to rationalize the denominator by cross multiply. 1 multiplied by e to the power x minus 1 equals to e to the power x minus 1 minus 1 times x, which is x, divided by x multiplied by e to the power x minus 1 when x goes to 0 from right. Now also by direct substitution, we have e power 0 1 minus 1 equal to 0, minus 0, we have 0 over 0 times 0, which is equal to 0. So you can use and apply the Hopital rule for this limit. So we have limit derivative up, which is e to the power x 0, and here we have minus 1, divided by the derivative of denominator, and in denominator we have multiply of two functions, so name x u and name e to the power x minus 1 as v, and use the product rule. U prime, which is 1, multiplied by v, so we have e to the power x minus 1, then plus u times v prime, so we have x multiplied by the derivative of v, which is e to the power x when x goes to 0 from right. Now for this one, you have also to plug in the value x equals 0 in the function we have. So we have e to the power 0 1 minus 1 0 divided by e power 0 1 minus 1 0 plus 0 times, so this gives us 0. So we have 0 over 0, so Hopital again. So you have to find the first derivative up and the first derivative down. Up, the derivative is e to the power x, and down we have e to the power x, the same, minus 1 0, and here you have to use the product rule. So we have u prime, which is 1 times v e to the x, plus u times v prime, so x e to the x when x goes to 0 from right. I think this is the last step, so you have to substitute and you'll get the final answer. E to the 0 equals to 1 divided by e to the 0 1 plus e to the 0 1 plus 0 times e to the 0 equal to 0. So the answer is 1 over 2. In part D, you have to find limit square root of x squared plus x minus x when x goes to positive infinity. By direct substitution, we have square root of infinity square, which is infinity minus infinity. So you have to convert it to 0 over 0 or infinity over infinity, use Hopital rule. So how to do this? Here you have to use the conjugate. And as you know, if we have a minus b, then a plus b is the conjugate of this term. And if we multiply a minus b multiplied by its conjugate, the answer is a square minus b square. So you have to multiply here by the conjugate up and down. So we have limit of square root of x squared plus x minus x, can write it over 1. Then you have to multiply up and down by the conjugate, and the conjugate is x squared plus x over square root of x squared plus x when x goes to infinity. So you have to multiply this expression with its conjugate, and the answer will be the first one square minus the second one square. So the first one square, you have to cancel the square root. So we have limit of x squared plus x minus the second one square, which is x squared, divide by 1 times this expression. So we have square root of x squared plus x when x goes to infinity. So x squared minus x squared equal to 0, and we have limit x over square root of x squared plus x when x goes to infinity. Now by a direct substitution, you will get infinity over infinity plus infinity, which is equals to infinity. Pay attention, infinity plus infinity equals to infinity, but infinity minus infinity, it is indeterminate form. So here we have infinity over infinity, so you can use Hopital rule and find the derivative up and down. But if you use Hopital rule, you will enter a maze. So don't try it. Check it by yourself and tell me in the comments. So you have to take the highest power up and the highest power down, and you will get limit of x over, here we have the highest power x to the power 2, but we have square root. So we have square root of x squared, and since x goes to infinity, the absolute value of x is equals to x. So we have x in the first term, and the highest one in the second term is x, because we have the same highest powers, you have to add them when x goes to positive infinity. So we have limit x over 2x when x goes to positive infinity. Then cancel x with x, you will get 1 over 2. For part E, you have to find limit x minus ln of 1 plus x squared when x goes to positive infinity. If you replace infinity here, you will get infinity minus ln of 1 plus infinity. Now infinity, this is a polynomial, so you have to take highest power when you want to find limit at infinity. So we have infinity squared, which is infinity, and ln of infinity equals to infinity. So we have infinity minus infinity. This is the indeterminate form, and you have to convert it to 0 over 0 or infinity over infinity to use Hopital rule. And as you know that len e to the x equals to x, so we can rewrite x as len e to the x. So we have limit len e to the x minus len 1 plus x squared when x goes to positive infinity. And since we have len minus len, so you have to write it in a single logarithm like this: limit of len e to the x divided by 1 plus x squared when x goes to positive infinity. And since len is a continuous function, so you can enter the limit inside the len we have. So we have len of limit e to the x divided by 1 plus x squared when x goes to positive infinity. Now you have to use direct substitution. E to the power infinity equals to infinity divided by infinity square, which is infinity. So you can use LHopital rule. So we have len of the limit f prime divided by g prime. So we have e to the x divided by 2x when x goes to positive infinity. Now again, by direct substitution, you will get e to the infinity, which is infinity divided by 2 times infinity, infinity. So you have to use LHopital rule again. So you have to find the derivative up and down. Then you will get limit len of limit e to the x divided by 2 when x goes to positive infinity. Again, by direct substitution, you will get e to the infinity, which is infinity over 2, which is infinity. So the limit inside equals to infinity, and we have len of positive infinity that gives us plus infinity. And this is the final answer for part E. And that's it. Thank you.